Get up a little closer.
Oh, it's gonna hit this house. No.
Oh, missed it.
Oh, God.
Yes! Woo! Get up there, get up there!
Bree, can you shoot? I can't.
Yeah.
There it is. Right, you're right. Right here.
We're in it. Thermal. Good evening, everybody. This is not live, but this is the Tipton, Oklahoma tornado from November 7, 2011. Really put a big exclamation point on a very active 2011 season. In fact, April of 2011 that year had more tornadoes than any month in recorded history. This tornado was actually rated an EF4. And I'm not saying that this Thursday and Friday, maybe even Saturday setup is going to end up like this, but it does have similar timing. It is a very large trough with a very large magnitude. I do think that tornado potential could happen Thursday night in the Texas handle up into southwestern Kansas. But then I think the tornado threat maximizes in Texas on Friday afternoon, and Friday evening. Northern Texas, central Texas, forecast soundings that are supportive of strong tornadoes, even like this one right here, Tipton, Oklahoma, EF4, November 7, 2011. Here you can see the roping out phase of that tornado as it is fully occluded all the way down to the surface. Usually that starts to choke off the surface inflow. You have basically an inflow layer at the surface, and then where it rockets straight up, that's the corner flow, 90-degree angle where that surface inflow goes all the way to the vortex and then is forced straight up. But this tornado here is very mature. It's starting to rope out, so there's actually even sinking motion dominating this tornado. It's basically separated largely from the mesocyclone. Sometimes these roping out tornadoes will get pulled back underneath the mesocyclone, and then they'll expand when they get pulled directly underneath that vacuum cleaner up above it. That's what causes tornadoes to form and also be maintained. And we sampled that vacuum cleaner with our rocket launch into the Linwood, Kansas tornado. Basically, the trajectory of that parachuted probe showed no curvature as it was going through the mesocyclone, reaching speeds up above 80 meters per second. A totally tilted pipe all the way up to the tropopause, and that's largely driven by the middle and upper tropospheric jet stream. So it's not driven as much by a vertical pressure gradient in that case, but really more due to the supercell being immersed inside of or within a jet stream, a strong mid and upper tropospheric jet stream. This is our late friend Andy Gabrielson, who was trying to back up out of the path of that tornado. One of the best close-range storm chasers we've ever known. Andy Gabrielson, back in the day there, was really close to the Tipton, Oklahoma tornado. He was trying to reverse, ended up getting a crosswind, rolled his vehicle. We picked up Andy and then resumed the chase. So we came up to that vehicle, pulled him out of his rolled over vehicle, and then we continued to chase that tornado as it moved up through the Wichita Mountains area. And just a remarkable EF4 tornado. Look as we were punching through the hook. This is called a hook slice right here, as you're basically going from west to east through the hook rain. This is the best approach for tornadoes, even though it can be relatively dangerous. You certainly do have to be experienced before you execute one of these hook slice maneuvers. But basically, I was going from west to east through the hook echo, pounded through all the rain and hail that's wrapping around the backside of the supercell, and then you get this perfectly clear view of the tornado, an EF4 tornado at that. The low pressure reservoir sitting up here, and then lobes of that pressure deficit will dynamically pipe down to the ground. They'll excite basically a cyclonic spin around those height falls as they propagate down toward the surface. Then you'll get another lobe that will propagate back down, and that'll excite that counterclockwise spin around it, basically the wind field adjusting to the height field here, and then as it eventually plants, and you saw that with the Andover, Kansas tornado, that as that low pressure was getting closer and closer to the ground, the intense vertical pressure gradient force would excite jet-like vortices beneath it, these rapid jets with almost near purely vertical motion. And then as that negative pressure reservoir would get closer to the ground, eventually planting, you basically see the subvortices develop this helical pattern until the low pressure reservoir plants. And one thing that we learned from our rocket launch is that really the strongest pressure deficits are largely located just above the ground, right up there. In this case, though, the pressure deficit did plant, and you get that cyclonic spin all the way down to the ground. You can also see that sinking motion on the outside of the tornado. That was our motivation for using a rocket to launch into a tornado, is that we need to try to get through that sheath of sinking air that encapsulates the tornado vortex. By definition, a tornado, at least a supercell tornado, is formed by an occlusion. Also, look at all this hail on the ground. And basically an occlusion is where you have a sheath of sinking air that cuts into the mesocyclone and excites a vortex that's on a smaller space and time scale than the overlying mesocyclone. And basically any area of rotation, even a gustnado that's able to propagate underneath that pressure deficit, that reservoir of lower pressure, once it starts to get subjected to that vertical pressure gradient force, it's very easy for that little area of vorticity to couple with the updraft, couple with the tornado cyclone, and then you get tornado genesis. And in our rocket paper, we did get a couple comments saying that tornado cyclone is a redundant phrase, but in my book, I use tornado cyclone to basically describe an occluded vortex that's on a scale smaller than the mesocyclone, but doesn't even have to have touched the ground yet. So when I see those massive cinnamon buns that are spinning around, trying to dynamically pipe down to the ground, I call that a tornado cyclone. Obviously, this is a tornado completely planted, damaging winds all the way down to the ground. This is a relatively mature tornado too, because that pressure reservoir, the low pressure, is planted all the way down to the ground. And once the occlusion is complete at the surface, a lot of times it'll even choke off the surface inflow layer. And at that stage, the occlusion is complete from the top down. And just incredible to see all the tornado dynamics that we've learned over the years happen out in the field. And up here you can see the tornado cyclone. It gets skinnier, of course, as it goes down closer to the ground. EF4 tornado starting to mature, gradually starting to rope out here. But just because it's starting to rope out doesn't mean that this isn't going to be able to get pulled back underneath the mesocyclone, and then sometimes it'll even re-intensify. You may remember the Pilger, Nebraska tornado, June 16, 2014. That was an incomplete occlusion where you actually had two simultaneous EF4 tornadoes in progress at the same time. And that happened a few times too with that supercell. So it produced the Stanton, Nebraska EF4 first, and then it produced the two tornadoes near Pilger that both became EF4s. And I believe that it happened 3 separate times where it had an EF4 tornado on the ground for that long of a period of time. So this is a fall season outbreak. They certainly do happen. This is the second season as the jet stream migrates back south from Canada. This is, they call it the second season, these transitional seasons of spring and fall. Spring, the jet stream is very invigorated, active right over central North America, even the southern sections of North America. And then in the summer, it lifts up into Canada, then comes back down during the fall season. And I actually witnessed my first ever tornado during the fall season, October 4 of 1998. That was my first tornado, a very significant outbreak, one of the largest outbreaks, I believe, in history in Oklahoma, if not the largest. But this is for Friday. I think that Friday looks like the tornado threat is going to be greatest across portions of northern and central Texas. You can see the photographs here overlaid on surface-based Cape. Friday forecast at 0Z, and this is a 3-kilometer NAM as well. And look at that surface-based instability nosing all the way up into central Oklahoma, and that's likely going to bring a tornado threat into central Oklahoma, at least southern Oklahoma on Friday. But we still need to hammer down all the details. We're still not even within 48 hours into the event. Likely still going to be some surprises. It looks like the 3-kilometer NAM must have some type of a double dry line structure as well. Main dry line back across the Texas Hill Country, and then an eastern dry line with greater moisture, 70s dew points streaming up, the nose of which make it all the way up to DFW. And look at that photograph. right on the nose of that instability, the greater instability